Hello everyone, welcome to today's webinar. Today is the final session on the series that covers the fourth unit in Algebra 1. I decided to add this session to discuss the radical equations. Originally, we had only 3 sessions in this series, but I decided to dedicate one separate session for radical equations. And thank you for signing up for this webinar. And today we will look at how can we solve radical equations. In the beginning, I just want to introduce myself. This is myself. My name is Miriam. I'm your math instructor here at Penn Foster. I'm sorry. And I am certified to teach high school math in the state of Pennsylvania. I just earned my master's degree in education this summer. Today, we're going to look at the different types of radical equations, the most challenging ones, and how can we solve them following certain rules that we need to learn how to do in order. Also, during this webinar, we're going to have some self-check questions. And as you know by now, those self-check questions are not graded. They are not evaluated. It's not an evaluation of your understanding. These are given for your own assessment. If you're not sure if you're good on that topic or no, do 1 or 2 of those self-check questions just to give yourself an idea of how or where you stand in that topic. Your questions are welcome. You can type them in the questions box. The raise your hand feature does not work in our webinars. So if you have a question, you can type it in the questions box, or it may say the chat box. I would imagine the questions box would be the right place to type in your questions. I'll be able to see the question and who asked the question. Please keep your questions relevant to what we talk about today in our presentation. All registrants will receive a recording of this webinar to watch at your convenience. Whether you attend or not attend, you will receive the recording. So, as I said, the main topic today would be how to solve radical equations. Let's look at some simple examples of a radical equation. These would be the simplest form of an equation given to you in a Discover More question or a practice question or an exam question. Now, we need to understand the goal of solving equations, radical equations. The goal is, and I have put these in that section of my slide, the goal is always isolating the radical expression alone in one side of the equation, and everything should be on the other side of the equation. Once we are able to isolate the radical expression, we square both sides of the equation, because remember from the last webinar, we said that we are able to get rid of the radical sign by squaring the expression, because squaring a number or a value is the opposite of taking the square root of that value. So if you square a radical expression, you will get rid of that radical sign, and you will end up with just normal variables and normal numbers, and you can just apply the rules of solving regular equations without the radical sign. So that would be the steps. This is going to be the plan that we're going to have in our head no matter what type of equations. There is one type at the end of the webinar that may not follow the same goal, but most of the types that we're going to look at today will have the same plan. So since we are looking at question 1, we already have the radical sign separated. So the next step, I'm going to square both sides, so I get rid of the radical sign. A common mistake that I see students do is that they are so excited on squaring that side to get rid of the radical sign, but they forget to square the other side. So please do not do that mistake. Square both sides so we keep the equation balanced. So when you square a radical expression, the result would be whatever under the sign, which is going to be only x, equals to 9 squared is 81. And that would be your answer. The variable that you're looking for the value for is 81. And that's it. So it is, yes, it is simple. but we needed to go over that just to set up the goal, the plan that we're going to follow for other types of radical equations. The same thing for question 2. The square root of 5y equals to 60. I have the radical expression isolated already, so the next step, square. Square both sides equals to 60. Now square and square. So when I square that, we'll end up with a 5y equals to 60 squared is 3,600. Now, I'm looking for the value of y. I have a 5y. If you look at this equation, it's just a normal equation that we went through. I would imagine in Unit 2, we learned how to solve this equation. Divide over 5 to isolate the variable and divide over 5. You will get the value of y. You divide 3,600 over 5. That will give you 720. That would be the value of y, and that would be the solution. Remember, if you have questions, you can type them on the questions box. Let's look at another type of equations here. What if we have a radical sign or a radical expression or radical plus or minus a number equals to a value? What should we do? Do we square both sides? And the answer is no. We only square when we isolate the radical in one side and the other things on the other side. So we are not ready to square yet. We need to prepare our equation first. So the way I'm going to do it is I'm going to bring the 8 to the other side. How I'm going to do that? Subtract 8 and subtract 8. And that will keep the equation balanced, but it's going to isolate the radical sign in the radical expression in one side. So the square root of t equals to, that's a 0, equals to 20 minus 8 will give you 12. Now I have a radical expression equals to a value. I'm ready to square, square, and square. So t equals to 12 squared is 144, and that would be your answer. That is your answer. Zaina is asking about the previous question. How did I get the 3,600? 60 times 60. That is 60 squared. So if you have a calculator, you can do 60 times 60 or 60 squared, or think about 6 times 6 is 36, but I have a 0 here, or actually it's a 10, so I'm squaring the 10, that would be 100, so 3,600 would be the square of 60. Did I answer your question, Zaina? If I did not, let me know. So back to these equations where we have to prepare the equation first. We have 2 times the square root of 3p equals to 36. I'm not going to be able to square. I need to prepare the equation. Isolate the radical expression by dividing over 2 and divide over 2. We're going to have on the left-hand side the square root of 3p equals to 18. Now I'm ready to square both sides and square the 18 as well. So 3p equals to 18 squared will give you 324. I'm looking for the value of p, but I have the value of 3p. Then divide over 3 and divide over 3. I'm going to finish it up here. Then p equals to divide this number over 3, and that will give you the value of p 108, and that would be the value of your variable. Okay, let's move to a second type of equations. What if we have to do multi-steps in order to prepare the equation? Well, we need to prepare the equation by isolating the radical expression at one side. What should we do first? Do we subtract 2 or divide over 2? which one comes first. If we remember from Unit 2, we said that we need to get rid of any numbers that added or subtracted first, and then divide or multiply. So in this case, I'm gonna get rid of the plus 2 here by subtracting 2 from both sides. So that would be a 0. So far I'm going to have 2, the square root of 11t equals to 24 minus 2 is 22. Now I can divide over 2 and divide over 2. The square root of 11t equals to 11. Not done yet. I need to square both sides and square the 11 here. So 11t equals to not 11, 11 squared, which is 121. Now I need the value of only t, not 11t, then divide over 11 both sides. So divide and divide. So t equals to 11. That would be your answer. Any questions so far? Anything that was not clear on the set of the questions that we have gone through so far? Okay, let's look at a self-check question. The one step that is not part of the solution of this equation, the square root of 7s minus 2 equals to 34. Which step from A, B, C, and D that you think is not part of the solution, the wrong step to do when you're solving this equation? I'm going to leave the screen for about 30 to 40 seconds, and then I'm going to switch my screen to give you the same question, but the ability to input your answers. So you can work on the question, and then I'll change my screen in a little while. Okay, let me change the screen. So the question saying which step is not part of the solution. So here you go. You can pick your answers now. Okay, let me share my answer then for those questions. So when you get the recording, you can pause and do the questions one more time just to make sure how did we get to that answer. The step that it's not true to do when you solve this equation is A. We do not square both sides when the radical sign or the radical expression is not isolated yet. In this case, we have this radical expression minus 2 and we squared both sides. Well, it's not, I mean, algebraically you can do that, but the steps that we learn how to do so we do not confuse ourselves is B, C, and D. These are the 3 steps that we will have in our solution. This step just needs to be done carefully, and if you don't do it carefully, you may end up with the incorrect answer. So we bring the negative 2 over, so we'll have a 32, and that's why this is correct. And then you can square both sides. So 7s equals to 32 squared. That is correct. And then divide over the 7 both sides, because remember, this number is the square of 32. So this is a correct step. This one is a little bit tricky. So if I would choose, I would choose this one not to be part of my answer. Any questions on that question? Anything that was not clear? Okay, let's move on to a little bit harder types of radical equations. Now, I only like to remind my students always that when you have a challenging problem like this one, for example, or the ones that we're going to see later, we do not overwhelm ourselves or think that the question is hard without even trying to apply what we have learned. So we're going to stick to the rule, we're going to stick to the goal, to the plan that we have in our head. If you have the radical expression isolated on one side and everything on the other side, no matter how big the radical expression, then we go ahead and square. And this is what we're going to do actually now. This expression is isolated. Then we are ready to square both sides. So let's square and square. So when we square the expression, whatever under the sign would be the result of squaring the radical expression equals to 6 squared is 36, because 6 squared is 6 times 6, 36. Now it's a normal equation, one variable and then other numbers. So we are able to solve that by subtracting 6 from both sides. That's a 0. So we're going to end up with 5x squared equals to 30. Now divide over 5 and divide over 5. That would be a 1. That would be a 6. Then x squared equals to 6. Now this step is tricky. To get rid of the square, we can do the opposite operation, which is taking the square root of both sides. Now, x squared, the square root of that would be just x, which what we're looking for. And our result actually will not going to be one answer. It's going to be two answers, either positive or negative, the square root of 6. So actually in this equation, x will have two values. X either equals to the square root of 6, or x might be the negative square root of 6. So whenever you take the square root of the x squared, make sure that you have this sign there, plus or minus, to indicate that this equation has two solutions. This variable has two values. Any question on that part of the question, on the problem? Let's do more. Okay, what if we have another equation like this one? Okay, the difference is we have a huge radical expression on the left, but we have a variable on the other side. We're used to having numbers on the other side. What should we do? Well, we're going to follow the same plan. Square, because we have the radical expression isolated already. So let's square both sides. So we're going to square the square root of 9x squared minus 32 equals to x square and square. Okay, so that would be 9x squared minus 32 equals to x squared. What should we do next? Well, I see x squared and 9x squared. Those are like monomials. If you go back to Unit 1 in this course, we remember that we are able to combine like monomials. And remember, like monomials, they have the exact variable part, x squared and x squared. So let's bring the x squared over to the left-hand side and combine. So we have 9x squared minus x squared equals to, I'm going to bring that to the other side. So I'm going to add 32 and add 32. So it's going to be positive 32 on the other side. Now, 9 minus 1. Remember, in algebra, we do not write the 1. 9 minus 1, I'm able to do that because, again, those are like monomials. 8x squared equals to 32. Now divide and divide over 8. X squared equals to 4. x squared equals to 4. I'm looking for the value of x. Then take the square root of x squared and do the same thing for the other side of the equation to keep it balanced. Since we're taking the square root of a squared variable, remember that this equation then will have two solutions, either x equals to 2 or x equals to negative 2. Why 2? Because the square root of 4 is 2. But since we are taking the square root of 4, our answer might be 2 or negative 2. So x equals to, if you want to rewrite it as plus or minus 2. Other questions? Any questions here? Are there any question in this part where we have two values for x? Okay, let's move on to a self-check. Solve this equation, which has a big radical expression on the left-hand side equals to a number 7. Which one is the solution of x? Is it plus or minus 7? Is it positive 7? Is it a positive or negative, the square root of 21, or positive or negative 21? I'm going to keep that for about 30-40 seconds and then switch my screen to input your answers. Okay, I'll give you the same question with a chance to share your answers. Okay, let me share my answer for this question. And the answer for this radical equation, the answer is C. C is the correct values for x, either positive, the square root of 21, or negative, the square root of 21. Anyone wants to see this equation solved? If you want to see this, how did we end up with this solution? Let me know. You can type in anything in the questions box to request so. Okay, I'll do that for Zaina then. So we have the square root of 2x squared plus 7 equals to 7. I'm ready to square because I have the radical expression isolated. So that will end up with 2x squared plus 7 equals to 49. Remember, we have to square the right side as well. Now I only have to rearrange my equation, subtract 7 from both sides. 2x squared equals to 42. Divide over 2, divide over 2, end up with x squared equals to 21. Take the square root of both sides to end up with the x value. X equals to positive or negative the square root of 21. We have to keep this answer as is. There's no more simplification to the square root of 21. 21, remember, does not have any perfect square factors. So that would be our final answer. I mean, you can rewrite that in decimal, but it's going to be so long and not accurate. So we always keep the answer like that. Any questions on how did we solve that? Okay. Let's go to the next type of equations. What if we have a big radical expression with a number added to it, like the 10 here? What should we do? The same thing that we did it for the simpler parts of the simpler types of the equations. We cannot square right now. We need to get that 10 to the other side of the equation. So subtract 10 and subtract 10. That's a 0, so we're done with this part. Now we still have the radical here, minus 23 equals to 15 minus 10 is 5. I'm ready now to square. Square, and don't forget to square the 5 as well. 6x squared minus 23 equals to 25, not 5. And then I need to bring the 23 or the minus 23 over to the next side. So I'm trying to isolate my variables. So add 23 and add 23. Remember that we do not divide over 6 yet. We have to get rid of addition or subtraction first. So that's a 0. 6x squared equals 2. Add those figures, and that would be 48. I still need to isolate the x squared, divide over 6, and divide over 6. X squared equals to 8. That's not my final answer. I need the value of x, not x squared. Then take the square root and take the square root. The square root of any squared number is that number. Then x equals to the square root of 8 can be simplified more. If you look on the right-hand side of this slide, I wrote our perfect square factors, and 4 actually is a perfect square factor of 8. So I can represent the 8 in terms of 4 times 2 equals to the square root of 4 is 2, so 2 will go outside the radical sign, but the other 2 will stay inside or under the sign. So x equals to plus or minus the 2 square root of 2. That would be your simplest form of the answer, and we did not forget our signs here, that we have 2 solutions. Other questions? Any questions that you have in mind? Okay, let's move on to another equation. Okay, lots of things to do before we square. We have to get rid of the 7 and the 5 here to isolate that radical expression and then square both sides. So am I going to divide over 5 or subtract 7? I'm going to subtract 7 first. So subtract 7 and subtract 7. So that would make here 5 times the square root of 3x squared minus 17 equals to 12 minus 7. It's going to be 5. So on the other side, we have a 5. That makes it easy for us because we have to divide over 5 and divide over 5. Then the square root of 3x squared minus 17 equals to 1. Square, because everything now is ready to be squared. 3x squared minus 17 equals to 1 squared is actually 1. And then I need to work to isolate the x, the variable. So add 17 and add 17 to both sides. So you have 3x squared, that's a 0, equals to 18. Now divide over 3 and divide over 3. Now x squared equals to 18 over 3 will give you 6. I'm looking for the value of x, not x squared. So take the square root of the x squared and the 6. X equals to positive or negative the square root of 6. Remember, 6 does not have any perfect square factors, so it should stay like that. So that would be your answer. Either x equals to positive the square root of 6 or negative the square root of 6. any other questions that you have, anything that you have in mind, or you have read your lessons and you found some discrepancy between what I do and what you have already read in your units, or everything makes sense. Okay, let's proceed to a self-check question. And this time, what step is part of the solution of the equation, the square root of x squared plus 5 minus 7 equals to 35? Which one is a solution, or a part of the solution of this equation? So we need to see which one is correct here. So again, I'm going to leave it for a few seconds and then switch my screen. Okay, I'm going to show the question and the possible answers as just the names or the numbers of those answers. Which one is part of our solution if we were to solve this equation? Okay, I have 50% of you saying C and 50% saying A. Okay, let's look at the right answer. And please, if you do get that question incorrect, it does not mean that you failed the course or the exam, or that you're never gonna get algebra. It just means maybe that you need to go back to the lesson, use one of the resources, watch the webinar again. But please don't give up if you have a question or 2 or 10 incorrect. You know, we want to keep trying and trying and seeking for help if you need help. Okay, so the right answer is C. C is the only right step that should be included in your solution. Here we squared both sides with having a minus 7 with the radical expression. That's incorrect. Here they subtracted 5. They brought that 5 from under the sign and just decided to subtract it. So that is incorrect. We do not do that. And then D, actually, they subtracted 7 instead of adding 7, because here is minus 7. I need to do the opposite. So the minus 7 step here is not correct. The only one is this one. This is the correct step among the 4 we have. Ariana is asking, how would you watch the webinar again? All registrants who registered with to have this session or to attend that session, they provided their email address. So whatever email address that you provided, you will get the recording to that email address. You will have a link. You're gonna click on that link, or actually it's a button. It says watch recording. You're gonna click on the button and you'll be able to watch the recording. And also mentioning the follow-up email. Also, there is a survey in that follow-up email to all registrants, whether you attend or could not attend today. And that survey is a short survey. We'll ask your opinion on the webinar. So I would ask you to just give your feedback on today's session. Let's look at more weird-looking equations, if that's the correct way of describing that. The square root of c minus 4 plus 2 times the square root of c plus 8 equals to 16. The different things here that we see in this equation number 1 is that we have 2 radical expressions. We have the square root of c and 2 times the square root of c. What should we do? In the first webinar in this series, if I'm not mistaken, we learned how to add radicals. So since the radical part here is the square root of c and it is the same as the square root of c here. Those radicals or those radical expressions are like terms. We are able to combine them into one radical expression. So let's rearrange the equation. I need to keep the radical signs on one side and everything else to the other side. What I'm going to do is I'm going to add 4 and add 4. I need to get rid of the 4. And also I'm going to subtract 8 and subtract 8. That's it. So far I'm going to have the square root of c, that is a 0, and then plus 2 the square root of c, that's a 0, equals to 16 plus 4 minus 8 will give you 12. And then I can combine those terms. 1 the square root of c plus 2 the square root of c is 3 the square root of c equals to 12. Now I have it like a regular one that we have seen before. All I need to do is divide over 3 on both sides so I can isolate the radical expression. 1 the square root of c equals to 4. Now the square root of c equals to 4. I need the value of c, not the square root of c. I need to get rid of the square root sign. I need to do like a reversed operation of that. So that would be square both sides. C equals to 4 times 4 is 16. So the value of c is one value. It is 16. Another equation that has two radicals here. The same thing. The only difference is that the second radical is on the other side of the equation. That's no problem. We can bring this radical to the left-hand side so we can combine the radicals. Remember, we only combine radicals if they have the same radical part, which they are. They have the square root of t, then it is a sign for us to go ahead and combine. So what we're going to do is we're going to get rid of the 14 here, move it to the other side. So add 14 and add 14. I also want to bring this expression to this side. So add the 7, the square root of t, and also add 7 square root of t. Okay, let's rewrite the equation then. -3 the square root of t plus 7 the square root of t, that is gone, that's a 0, equals 2, that's a 0, and then 10 plus 14 will give you 24. Combine, -3 plus 7 is 4. Remember, one is a negative number and the other one is a positive number. Then we have to subtract. The answer has to have the sign of the bigger value. 7 is positive, then our answer is positive 4. The square root of t equals to 24. And then I need to isolate the radical. Divide over 4, then the square root of t equals to 6. Square, since we have the radical already isolated, and square, t equals to 36. And that would be your answer, one value for t. Zaina is asking, how come 4 squared is 16? Remember, when you square a number, you multiply the number times itself. So for example, 4 squared does not equal to 4 times 2. 4 squared equals to 4 times 4. 2 times, that's why the exponent is 2. Okay, another example, 10 cubed equals to 10 times itself 3 times, because we have a 3 as an exponent here. 10 times 10 times 10. So 10 cubed does not equal to 30. It equals to 1,000. So the number here on the top on the exponent will tell you how many times you're going to multiply the 4 by itself or the 10 by itself. Did I answer your question, Zaina? Okay, you're welcome. Any question on solving the second equation here? Okay. So far what we have been doing is check if the radical expression is already isolated in your equation, go ahead and square and then solve as you need. If the equation is not ready yet to be squared because your radical expression is not alone on one side, you need to rearrange your equation. So you get to that step where you have to square to get rid of the sign, only when the radical expression is on one side. Okay. Okay, Jessica is asking about the second one. She does not understand a step or so in the second one. Jessica, can you tell me which step that you did not get in the second question? Like which one? Is it the one that we rearranged the equation, or which one? I'm just waiting for Jessica's response. Okay, let's do it another way. Anyone else want to see how we arranged or rearranged equation number 2 to be able to solve it? Anyone wants to see that? If you want to see that, you can type in 1, for example, so that 1 would be a sign for me to do it. Okay, I'll do it for you guys. Okay. Let's do it one more time. I'll try to do it differently just to give you the idea of rearranging things here. I'm going to erase everything and do it from scratch. I know that some of you already know how to do that, but the benefit of a live webinar is that if any student had a question, they are able to get a live answer. So let's do that together one more time. Okay, so let's look at the equation. I need to bring this radical to the other side. What should I do? Well, since it's a -7 the square root of t, then add 7 square root of t to both sides. Okay, so let's reevaluate that. So that would be -3 the square root of t, which is this part, plus the one I brought from the other side, 7 the square root of t. I still have -14 equals to, that's a 0, and then I have a 10. I need the radicals to be on one side, but I have a -14, then add 14 to bring it to the right side and add 14. Let's rewrite. So far we have -3 the square root of t plus 7 the square root of t, that's a 0, equals to 24. Now I can combine -3 plus 7 is 4. +4 the square root of t equals to 24. Now I need to isolate the radical, but it's times 4, then divide over 4 and divide over 4 to make it alone in one side. The radical of t equals to 6 because 24 over 4 is 6. Now I need the value of t, not the square root of t, so I need to reverse the square root of t, then square and square. T equals to 36. So these are two different ways to rearrange the equation. You can write them both and try them both and see which one is more convenient to do. Let's look at another type of equation. Now, if you look at the equation here, we have two radicals. One, the square root of x, but the other one has a different value under the sign. So obviously we are not able to combine this radical with this radical. We are not able to. What should we do next? Even if I put that 3 to the other side and brought this radical to this side, it's not going to help. We are not able to combine still. What should we do in that step? Now, this is the exception type of equations where you square when you are not having the radicals isolated because you are not able to isolate them. Even if you brought this 3 here and this radical here, you're still going to have two separate radical expressions. So if you have this type of equation, this is the exception, you go ahead and square both sides. That's the only way you can do it. So square and square. Okay, now this step has to be done carefully. Remember, in the first self-check, we had that one, number A, one of the steps that we do not want to be part of our answer. I said at that time that it is a correct step, but we have to do it carefully. That applies to this step. How can we square the square root of x plus 3? Okay, and I just want to make sure that everyone can hear me clearly. Is everyone okay? Do you hear me? Or something has gone wrong in my... If anyone can just verify. Okay, good. So I want to continue on squaring this side. Now this side, if you remember from unit 1 in this course, we said that when you square a binomial, you do not only square the first term and the second term, but you have also to multiply 2 times this term times that term. Let me write the rule out and remember that you want to go back to unit 1 and remember that if you have a binomial, an expression that has 2 terms like A plus b, and you're trying to square the binomial, like the case here that we have, equals 2, then you have to square the first term, square the second term, and also multiply first times second times 2. So that would be 2ab. That's the rule that you want to apply when you square the left side. This is a tricky part. So let's square according to the rule here. Square the square root of x will give you x. Square 3 will give you a positive 9. And then multiply 3 times the square root of x times 2 will give you 6. The square root of x. This term, this expression is the square of this side. Equals to, that's normal here, just get rid of the sign, x plus 21. Before I go further, any questions on how did I square the first side or the left side? Okay, so let's just go over on why did we decide to square and then how did we square. We decided to square as a first step because there's no way for us to isolate the radical and only have one radical in this equation. No matter what we do or rearrange stuff, we will always have two different radical expressions. So we decided just to go ahead and square. Square the left side and square the right side. The right side is not a problem. We know how to do that. The left side is the one that we need to be careful when we square. When you square a binomial, meaning when you square two terms together, you need to follow the rule. Square the first, square the second, and then multiply first times second times 2. And this is what we have done. Square the square root of x would give you x. Square the 3 will give you 9. And then multiply first times second times 2. So that will give you 6 the square root of x. And from here, we are able to rearrange the equation. Let's bring the x's, this x beside that x, and see what's going to happen. So subtract x and subtract x and see what's going to happen. That's a 0 and that is a 0. So the x's have just canceled out. My equation now looks like this: 6 the square root of x plus 9 equals to 21. It's getting simpler. Now it just looks like a regular equation that we have been dealing with. Minus 9 and minus 9 to bring that 9 over to the other side. That's a 0. Then 6 the square root of x equals to 21 minus 9 will give you 12. Divide to isolate and divide. The square root of x equals to 2. Square both equations since we have the one radical expression on one side, and square the 2. X equals to 4, and that would be your answer. Any further questions on this problem? Remember, you can watch this webinar when you receive the follow-up email, and you can click on watch recording, and you'll be able to maybe stop the recording, do the problem yourself, and then look at the solution. Let's look at the question that have 2 separate radical expressions. You cannot combine them, but you don't have anything else with the equation. No addition, no subtractions, no numbers, nothing. Just 2 big radical expressions. What should we do? Square. Square both sides. If you square both sides, you will get directly rid of the square root signs. So that would be 5x plus 10 equals to 20x minus 35. We don't have any radicals here, only x's. So that's a regular equation. We just have to rearrange the equation and end up with an x equals to a value. Bring the 20x over to that side so it's beside the 5x and see how we can combine them. So minus 20x and minus 20x equals to 5 minus 20 will give you a negative value, negative 15x. I still have plus 10 equals 2, that's a 0. Negative 35. Remember this sign here? We cannot forget that. It's a minus or negative. So that's why it's a negative 35. Next, get rid of the 10 and put it other side, minus 10 and minus 10. So we're going to have negative 15x, that's a 0, equals to, we have a negative number minus a number, or negative plus a negative. Then you add the values and keep the negative sign. 35 plus 10 will give you 45, but your 45 will be a negative because both values are negative. Divide over 15 to isolate the x, and divide over 15. Remember, negative over negative is a positive. Positive 1x equals to positive 3. And x equals to 3, and that would be your final answer. Any questions on that problem? Okay, we have looked at different kinds of radical equations. Most of these equations are part of your lesson, so I try to bring in different equations, but have the same concept, have the same level of difficulty. So this webinar can be relevant to what you study and what you may see in the exam. So we looked at how to solve radical equations with one radical, two radicals, and two like radicals. And we learned that our goal is to isolate the radical expression if it's possible. If it's not possible, then we just square both sides like the last two problems that we've done. And also we learned that when you square a binomial, we need to recall the rule that we go by when we square a binomial. For studying for that exam, of course, you want to go and read your lesson. You're not going to depend only on this webinar or maybe your memory of the high school years when you've done radical equations. You want to go ahead and learn the topic one more time. You want to do the discover more questions or the practice exercises, whatever they're called in your unit. The answer key for those questions are provided. So whenever you work on those problems, you can check your answers with the answer key. If most of your answers are correct, then you're ready for the exam. If most of them are incorrect, then do not proceed to the exam, please. You can watch that webinar as well as a resource. And also you can go to khanacademy.org and go to the top left button that says subject and then click on Algebra 2. And from there, you're going to choose the lesson that says radical relationships. And then under that, you're going to click on solving square root equations. This lesson is the closest one to the ones that we have within the scope of our study unit. Within those Khan Academy presentations, you will hear the word extraneous solutions. We did not discuss that in this webinar or the study unit. So if you hear extraneous solutions, I just want to let you know what it does mean, but you will not be asked about that in the exam. It means that when you solve a radical equation, you algebraically, you find out multiple solutions to the variable, but not all solutions would be a real solution that you can use. So you do a check and see which one looks like a solution, but it is a false solution. That would be the extraneous solution, and which ones are really the solution to the equation. It's a process. It's another bunch of steps. Just ignore the sections that says anything about extraneous solutions. Next, what can you do to seek help? You can call the school from 9 to 6 Eastern Time on weekdays. If the instructor or the TA that you're trying to reach, they are doing their webinars or a meeting or eat lunch, they will give you a call back. Also, you can schedule an appointment at a time and a day that suits you. You can use this link here and you can choose which course and you can choose a time and the day, and we'll call you back on those specific days and times. If you have a brief question and you do not want to call or email, you can text message learn to this number and you just type in your question and we'll get back to you as fast as we can. Okay, Zaina, you're welcome. How would you email your instructor? If you have an extended question, you want a good explanation to what your questions are, you can email. Now, these two parts of the screen represents the two different accounts that your account may be on. Some of you have this view of the account or the interface here, or some of you have this kind of interface. I have the steps on those little squares, so choose which type of account you have and follow the steps to be able to email your instructor. Thank you for your attendance and participation. And thanks for everyone who registers for this webinar. As I said before, there is a 3-question survey, short answers really. I would appreciate your feedback to do better in my future webinars and also know what was good that you liked about this webinar. If you have general questions for me, you can go ahead and ask them. I'll be happy to assist you with that. If you do not think of any questions, you still can reach us through phone, text message, email, or you can make an appointment with one of the staff members at Penn Foster here. Okay, I wish everyone good luck in the exam, and please take your time and you can use that webinar. And if you have questions on that webinar, you can send me your questions through email. Good luck for everyone and have a nice morning.